Hey kids, today we are talking slope in three forms. So I am on page 34 of your notebook and we're going to fill out, we have three questions to work. So we've got slope in three forms. On the left-hand side are your three forms. So you can be given 2 points, you can be given a table, or you could be given a graph and asked to find the slope. And we're going to do one of each. So let's take a look at this first one. It says to use the 2 points and the slope equation to find the slope between the 2 points. Okay, great. You may remember this from last year. This might be something that you were asked to use or to memorize. That's wonderful. This is the version I like, and that's the version I'm going to talk about. So these triangles mean something. These mean change in. So these literally say change in y divided by change in x. So it's the change in your outputs over the change in your inputs, the change in your range over the change in your domain. So in order to find the change in y and the change in x to calculate slope, I'm going to need to know which of these numbers are x's and which of these numbers are y's. So yes, you are in math, but the alphabet is still a thing. X comes before y in the alphabet, so this is an x, this is a y, this is an x, and this is a y. Okay, that's kind of all I need, but I think I'm going to organize myself a little bit better. If I'm supposed to find the change in y, they're too far apart. I can't see it. So what I'm going to do is I think I'll put my y's together and my x's together. But I also can't take my inputs and outputs away from each other. So I'm going to write it like this. And I'm going to put 5 with -3 because they still map together. 5 was my x value, -3 was that y value, and they still map inputs and outputs together, just like with functions last week. Same thing for the other point. -4 and 3 still map to each other, so I have to keep them side by side. But now I can count. So I'm going to count. I'm going to start at -3, and I'm going to count up to 3. I'm going to get 6. So the change in y between -3 and 3 is 6. -3 plus 6 is 3. So the change in y is 6. Do it again for x's. If I start at 5, this time I'm going to have to count down to get to -4. I'm going to have to count backwards, but it's going to take me -9 to get there. So this slope, this change in x over change in, or change in y over change in x is 6 over -9. And that's right, and that's great, and that's wonderful, but it simplifies. So I'm going to clean it up, dividing top and bottom by 3 to get 2 over -3. And I'm going to use that as my final answer for my slope. All right, the rest of the question says now to use the slope to get 2 more points on this line. So your slope is a pattern. All we have to do is continue the pattern. So I'm going to use, and you kind of get to choose, I'm going to use these numbers I already have. I went from -3 to 3 by adding 6. What if I add 6 more? What if I keep the pattern going? Where would I be now? Well, 3 plus 6 is 9. What if I added 6 more? I'd be at 15. And then I'll do the same thing over with my x's. If I subtract another 9, I'm already at -4. Subtracting 9 puts me at -13. If I do it again, I'm at -22. And so these inputs and outputs go together and they create 2 new points. So 2 other points on this graph would be -13, 9, input output xy, and -22, 15. Are those the only other 2 points on this thing? Of course not. Those are just the easiest ones for me to find by keeping the pattern going. Okay, that's how you find slope using the slope equation, change in y over change in x. Now we're going to go find slope using a table. And joke's on you, we just found slope using a table. This is a table. So we're actually just going to do the exact same thing. So I always start with y's first so that I don't get them backwards. We're going to go find the change in y. How do I get from 6 to 4? I subtract 2. I better do it again to make sure I'm right. How do I get from 4 to 2? Oh, good, I subtract 2. So my change in y is -2. On this side, how do I get from -1 to 0? I add 1, 0 to 1, I add 1. Great, the pattern's still going, so my change in x is 1. To put it together for slope, I do change in y, which was -2, over change in x, which is 1. You're welcome to leave that, but it simplifies down to just -2 by itself. Then to go calculate more points, I'm going to keep the pattern going. So I subtract 2. If I subtract 2 more, that puts me at -2. If I subtract 2 more, that puts me at -4. If I keep the pattern going for x's, I add 1 to get to 2, I add another to get to 3, I add another to get to 4. And so there's your 2 other points. These are 3, -2, and 4, -4. You put your input, then your output, your x, then your y. The last one is usually the one the kids like most. Usually when I say slope, the first thing they say to me is rise over run. Great, that's what we're going to do. We're going to rise and we're going to run. Please know it's the same thing. Your y values, when I plot something on a grid, y values are measured up and down. X values are measured left and right. So when you're rising and you're going up and down, you're finding a change in y. When you're running and you're going left, right, you're finding a change in x. So here we go. I need to plot these 2 points first. So the first point I'm supposed to plot is 0, 3. So that means my x value moves nothing, my y value moves 3. So if x moves nothing, y moves up 1, 2, 3 is here. When I plot the point 4, 1, my x moves 4. Positive 4 means go to the right. 1, 2, 3, 4. My y value moves up 1. And now we're going to go calculate rise and run. I choose to do this reading left to right because that's how I read books. I start with the left point and I go to the right point. So if I calculate how far I have to move vertically, up, down, rising, to get from point to point, it would be this distance. The fact that I had to go down means it's negative. So that rise is a -2 rise, means I went down 2. This run is counting 1, 2, 3, 4, a distance of 4. I move to the right. That makes it a +4. Moving to the right is a positive. Moving left would have been negative. So our slope is going to be rise is -2, run is 4. I'm going to simplify it down. 2 divided by 4 is the same as 1 divided by 2, so a -1/2. We're supposed to find more points on this line, so I'm going to keep the pattern going. This time, I'm going to do the simplified pattern to keep going. I didn't do that everywhere because I wanted you to know that there are options. But if I treat this as my rise and this is my run, I'm going to keep the pattern going of rising -1, running 2. So the negative means I go down. So I'm starting at the leftmost point, and I'm going to go down 1. If I run 2, you always run right. I always run to the right. So 1, 2. Down 1, right 2. Down 1, right 2. I could do this all day long. I'm going to fill out the whole grid. What if I ran out of space? I could go the other direction by going up and to the left. As long as your dots end up being in a straight line, then you've done a good job. And that's kind of the beauty of being able to do these graphically is you know you've done a good job because you have a line or you don't. If your line gets all jiggy-jaggy, that's not a line. So I'm going to connect the dots, put arrows on the end to say that I know it goes forever, and draw a first line. We're about to draw very, very, very many more lines. That's what's coming next.